Hi, in this module I will discuss how to represent the stresses at a point using graphical method. This graphical method is called as Mohrs circle. Consider state of stress at a point. The stress element for this plane state of stress at a point can be represented like this. The stresses on two mutually perpendicular planes, that is plane AB and plane AC, are given at this point, and stresses on any nth plane CB are to be found. We have learned that stresses on any nth plane making an angle theta with the vertical are sigma nn and tau nt. Analytically, sigma nn can be written as sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta, and tau nt can be written as minus sigma xx minus sigma yy by 2 sin 2 theta plus tau xy cos 2 theta. We can obtain the equation of Mohrs circle from these two analytical equations in this manner. From the first equation, we can write sigma nn minus sigma xx plus sigma yy divided by 2 equal to sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta, squaring the entire equation. Similarly, squaring the tau nt equation. Now we can add both these squared equation. On addition, we will get sigma nn minus sigma xx plus sigma yy by 2 plus tau nt square on the left side. On the right side, we have this term which we call as A and this term which we call as B. So here we have minus A plus B whole square, and here we have A plus B whole square. So we will get A square plus B square minus 2AB from this equation, and A square plus B square plus 2AB from the bottom equation. If we look at the term A, we will have sigma xx minus sigma yy by 2 on the top. Similarly, sigma xx minus sigma yy by 2 on the bottom, which will come as common, and sin square theta plus cos square theta will become 1. Similarly, tau xy square will come as common, and cos square theta plus sin square theta will become 1, and minus 2ab and plus 2ab will cancel each other. Therefore, on the left hand side we will get sigma xx minus sigma yy by 2 whole square plus tau xy square. Now, if we compare this equation with the equation of a circle, which is x minus a whole square plus y minus b whole square equal to r square, we can see that instead of x we have sigma nn, in place of y we have tau nt, in place of a we have sigma xx plus sigma yy by 2, and in place of b, that is tau nt minus 0 whole square, we have b equal to 0, and the radius of Mohrs circle r is equal to sigma xx minus sigma yy by 2 whole square plus tau xy square, and the center of Mohrs circle is given by a comma b. Therefore, we get the center as sigma xx plus sigma yy by 2 comma 0. So we have obtained that graphically the state of stresses at a point, that is sigma nn and tau nt on any nth plane, can be represented using this equation, which is called as Mohrs circle. To draw Mohrs circle, we need to follow the Mohrs coordinate. In Mohrs coordinate, x is replaced by sigma nn and y is replaced by shear stresses, that is tau nt, and the center of Mohrs circle will be given by this and radius as this. Now I will discuss how to draw Mohrs coordinate. For drawing Mohrs coordinate, mark normal stresses on horizontal axis, because instead of x we have sigma nn, that is normal stresses. Tensile normal stresses are marked on the right side of the origin and compressive normal stresses are marked on the left side of the origin. The following animation makes this clear. This is the horizontal axis on which the tensile stresses are marked on the right and the compressive normal stresses on the left. On the vertical axis, mark shear stresses, because in place of y we have tau nt, that is shear stresses. Shear stresses tending to turn element anti-clockwise are marked below the origin. Look at this animation that clears how the shear stresses tend to turn element in anti-clockwise direction. This is the stresses at point A. This tau xy and tau xy are tending to turn the element in anti-clockwise direction, like this. So this tau xy will be marked below the origin. Similarly, shear stresses tending to turn element clockwise are marked above the origin. Consider this stress at a point. This tau xy and tau xy are tending to turn the element in clockwise direction, like this. Therefore, this tau xy is to be marked above the origin. Therefore, on the vertical axis, clockwise shear stresses are marked above the origin and anti-clockwise shear stresses are marked below the origin. So we get the Mohrs circle coordinate like this, where the x-axis represent the normal stresses and y-axis represent the shear stresses. Certain points are to be noted for drawing Mohrs circle. First is, each point on a Mohrs circle represents a particular plane passing through point A. For example, this is point A. At point A, vertical plane is AB, horizontal plane is AC, and CB is some nth plane. The vertical plane AB can be marked on this Mohrs circle at some point V, and the horizontal plane AC can be marked on this Mohrs circle at some point H. Similarly, the nth plane CB can be marked on the Mohrs circle at some point N. Therefore, each point on a Mohrs circle represents a plane. Now, the coordinates of any point on Mohrs circle are sigma nn and tau nt, because x-axis represents the normal stresses and y-axis represents the shear stresses. Now, since each point represents a plane, therefore the x-coordinate of the Mohrs circle will give you the normal stress on that plane, and the y-coordinate will give you the shear stress on that plane. That is, if this is the plane CB, which is the nth plane, then the x-coordinate will give you the normal stress sigma nn on this plane, and the y-coordinate will give you the shear stress tau nt on plane CB. I will discuss how to draw Mohrs circle if the stresses on two mutually perpendicular planes, that is plane AB and plane AC, are given at a point. Following steps are to be followed. First is, label vertical plane as P and horizontal plane as H. Now write the coordinates of the vertical plane and the horizontal plane. On the vertical plane, normal stress is sigma xx and shear stress is tau xy. So we write the coordinates of vertical plane as x coordinate is normal stress, which is sigma xx, and you have to mention whether this normal stress is tensile or compressive. In this case, normal stress sigma xx is tensile. On the y coordinate, you have to write shear stress tau xy. Now this tau xy is trying to rotate the element in anticlockwise direction. Therefore, we put anticlockwise arrow with shear stress tau xy. The coordinates of horizontal plane H can be written as normal stress sigma yy. Again, sigma yy is tensile, so we mention T, and the y coordinate is tau yx, which is the shear stress, and this tau yx is trying to rotate the element in clockwise direction. Therefore, we mark a clockwise arrow with the shear stress tau yx. So the rotation arrow shown with the shear stresses corresponds to the rotation of the cube caused by the shear stresses. For example, in this case, the shear stresses are trying to rotate this cube in anticlockwise direction, and in this case, tau yx is trying to rotate the element in clockwise direction, and T or C indicates that the normal stress is tensile or compressive. Now we will plot points B and H on the Mohrs coordinate. The Mohrs coordinate can be drawn like this. So for marking the vertical plane V, we first mark sigma xx on the Mohrs coordinate. Since sigma xx is tensile, so we have to mark this on the right side of the origin, as right side of the origin represents tensile stresses. So sigma xx can be marked like this. The y coordinate is tau xy. Now since the arrow is in anticlockwise direction, therefore this tau xy is to be marked below the origin, as anticlockwise shear stresses are marked below the origin like this. So we get point B. Similarly, for marking point H, normal stress is sigma yy, which is again tensile, so it has to be marked on the right side of the origin. In this case, let us assume that sigma xx is greater than sigma yy. Therefore, sigma yy can be marked like this. The y coordinate is tau yx, which is to be marked on the vertical axis. The arrow shown with the tau yx is in clockwise direction, so it has to be marked above the origin, as clockwise shear stresses are marked above the origin like this. So we get point H like this. Now we have marked the vertical plane and the horizontal plane B and H. Now in the fourth step, join horizontal plane and vertical plane through a straight line. The point where the straight line HB cuts the normal axis is the center of Mohrs circle C. Now CB or CH as radius, we can draw the Mohrs circle like this. So we have obtained Mohrs circle from the state of stresses given at a point on two mutually perpendicular planes, that is the vertical plane and the horizontal plane. Now certain points about Mohrs circle are to be noted. The first one is the angles between planes on stress element are doubled when plotted on a Mohrs circle as explained. Consider this element. The Mohrs circle for this element can be drawn like this, where V and H represents vertical and horizontal plane and C is the center of Mohrs circle. Suppose we want to find the stresses on some nth plane. If the stresses on any nth plane making an angle theta with the vertical at this point are to be found from the Mohrs circle, then we have to first locate the plane CB, that is the nth plane on the Mohrs circle. For this, we see that the angle which the plane CB makes with the vertical is theta on the stress element. Now, on the Mohrs circle also, we will take angle from the vertical plane only, that is the plane CB, and the angle is to be measured in the anticlockwise direction from plane CB. But if the plane is making an angle theta with the vertical in stress element, on the Mohrs circle we have to mark angle 2 theta, that is twice the angle as that on the stress element, because while deriving the equation of Mohrs circle, we eliminated 2 theta from the analytical equations. Now we draw a line from C. The point where this line cuts the Mohrs circle is the plane CB. Therefore, when plotting angles on Mohrs circle, they are to be doubled as compared to angles on the stress element. Now we will see how to find principal stresses and principal planes from Mohrs circle. Principal stresses are the maximum and minimum normal stresses at a point. On the Mohrs circle, it is clear that this plane is having the maximum normal stress because the x-axis represents the normal stresses. Therefore, the normal stress on this plane is sigma 1, and this plane can be seen to be representing the minimum normal stress. Therefore, the normal stress on this plane is sigma 2. Suppose this is the vertical plane, then the angle 2 theta 1, that is angle of the principal plane from the vertical plane, is this angle. This angle will be 2 theta p1, that is twice the angle theta p1. Similarly, this angle is 2 theta p2, that is the angle of principal plane 2. Now, maximum shear stresses and their planes from Mohrs circle. The shear stresses are marked on vertical line. Therefore, this point is representing the maximum shear stress and this point is representing the minimum shear stress. If this is the vertical plane, then this angle is 2 theta s1 and this angle will be 2 theta s2. Cm and Cn are the radius of Mohrs circle. Therefore, we get that radius of Mohrs circle is equal to maximum shear stress at a point. Now, let us see certain examples on how to draw Mohrs circle. Consider a state of pure shear stress at a point, that is, there are no normal stresses at this point. Now we first find the center of Mohrs circle. Center of Mohrs circle is given by sigma xx by sigma yy by 2, 0. Since both sigma xx and sigma yy are 0, we get the center of Mohrs circle as 0, 0. Radius of Mohrs circle is given as under root sigma xx minus sigma yy by 2 whole square plus tau xy square. Therefore, we get the radius of Mohrs circle as tau xy. To mark the Mohrs circle, we first make Mohrs coordinate. Now the center is coinciding with the origin and the radius is tau xy. Therefore, Mohrs circle can be drawn like this. So for pure shear state of stress, Mohrs circle is having the center at the origin. Example 2 is of hydraulic state of stress. A hydraulic state of stress is a stress in which the stresses acting at a point are only the normal stresses and the normal stresses sigma xx and sigma yy are equal. It may be tensile like in case 1 or it may be all compressive like in case 2. Let us draw the Mohrs circle for case 1. The Mohrs circle for case 1 and case 2 will be similar except that in this case it will be positive and in this case it will be negative. So for case 1, sigma xx is sigma and sigma yy is also sigma and tau xy is 0. So therefore we get the center of Mohrs circle as sigma xx plus sigma yy by 2, 0 equal to sigma, 0, and the radius of Mohrs circle r is given by under root sigma xx minus sigma yy by 2 whole square plus tau xy square. Since sigma xx and sigma yy are equal, therefore we get sigma xx minus sigma yy as 0 and tau xy is also 0. Therefore we get the radius of Mohr circle as 0. Therefore the Mohr circle for this state of stress is a point like this. To understand this point Mohr circle, imagine a bigger Mohr circle at this point like this. We have learned that each point on a Mohr circle, whether this point or this point, all points are representing a plane passing through a point A, and the coordinates of these points, that is the x coordinate and the y coordinate, are giving the normal stresses and the shear stresses on the plane represented by this point. In this case, since all the planes have shrink to this point like this, therefore the stresses of all the planes at this point, that is whether this plane or this plane or vertical plane or horizontal plane, are same, and each plane will have only one normal stress, that is sigma, and no shear stress. On this plane also we have sigma, on vertical plane also we have sigma, on horizontal plane also we have sigma. So all the planes will have equal state of stresses, that is normal stress is sigma and shear stress is 0, because all the planes are represented by a point and the x coordinate of all the planes is sigma only. In example 3, it is to be noted that Mohr circle center always lies on the horizontal axis. We have learned that the coordinates of center of Mohr circle are sigma xx plus sigma yy by 2, 0. Since the y coordinate of the center is 0, therefore Mohr circle center must always lie on the horizontal axis, that is the normal axis. This ends this module.